We will take a look at one more example of these parametric functions in case you need a little bit more help here. So here's another one. Our parametric function is that x of t is equal to sine of t, and y of t is equal to 2 sine of t. You can see it written either this way or this way. They mean the same thing. So what we will do to figure out what a graph of this might look like is take a look at a table of values where for a bunch of different t values, we will figure out both the x and the y at that moment in time, and then we will graph it. So let's run through some values for t. Starting at t equals 0, well, the sine of 0 is 0, and 2 times the sine of 0 is also 0. So we know we're there. At the sine of, let's go to pi over 6. So after a very little amount of time has passed, the x value is the sine of pi over 6, which is 1/2. And the y value is 2 times the sine of pi over 6, which is 1. So the next point, let me mark, just scale this a little bit, so it's somewhat even. So the next point would be at 1/2, comma, 1. And then, let's see, another y value we could pick. Let's go pi over, just do pi over 2. The sine of pi over 2 is equal to 1, and 2 times the sine of pi over 2 is equal to 2. So the next point we'll see here is 1, 2. Now I want you to notice that something interesting here is these values and what we see on the graph, that this function is going up at a constant root like this, does not, sorry, at a constant slope, does not tell me anything about how quickly that point is going up. That's important. We'll see that in a second when we look at Desmos. I'm going to graph a couple more values here. 5 pi over 6, so a little bit more time has gone by. Our x value is back down to the sine of 5 pi over 6, and the y value is still double that. So we're here. So the point has gone up. They kept going up, and now it's come back. And if we keep going here, we'll see that it will just keep going. The sine of pi is 0, and so is 2 times the sine of pi. The sine of 3 pi over 2 is -1, and double that is -2. So we will also go through the point -1, comma 2. So the graph will have gone to there before it turns around and comes back. By the time 2 pi seconds has elapsed, the x value is back to 0, and so is the y value. As the time keeps increasing, we'll just keep repeating over this pattern over and over again because both the x and the y are sine functions. So they are periodic. If we take a quick look at what this looks like on Desmos, we can start by making a table of values again. I'll call this T1, and the sine of T1, and the x value. Sorry, the y value is 2 times the sine of T1. And so I'll use the same x values that I had here. 0, pi over 6, pi over 2. You can see these are the same values that we made in our table before. And if I want to graph all those points, I can graph the sine of T1, comma, 2 times the sine of T1. You can see all those points that we graphed. Now if I want to see it as a line with all of the points in between, I'll do it without that T1, because the T1 in Desmos refers back to the numbers that I put in here. If I want generic sine of T, 2 sine of T, or I can pick whatever numbers I want here. Well, type an extra t, that ruins it. And there's the line that we drew. And then I showed you this in the last video. I'll show it to you again. If you want to, you can use a slider instead of the variable t. And so then I can control, I'll go from 0 to 2 pi. And you can control, you can watch the point go. Notice how, I'm going to slow it down a little bit so it's a little bit more obvious. Notice how it goes much faster in that middle section than it does to the edges. Oh, it's much faster in the middle, and then it slows down, and then it speeds up in the middle here, and then slows down again. It might surprise you to learn that the next thing we're going to talk about is that speeding up and slowing down, which will connect to the derivatives of the parametric function, and that will be in our next lesson.